All right, number 4, I want to show you the image of this because square roots or radical functions don't have that power up there that you see, but you do have a little exponent on the inside that kind of helps. Let me go back to the graphics. So this is in our Blackboard course, in our content folder. In module 2 is where I have placed the parent function graphs. So let's just go to the first one. There's 2 of them. The original one. Let me make this full screen so you can see what I'm looking at. So look, this square root symbol, it doesn't have any symmetry. It says neither. And if you look at all these graphs, it's kind of showing you the type of symmetry it has. It's telling you the name of the function, it's linear, and the symmetry it has. This is odd, absolute value, which doesn't have one, is a little bit different as well. It's even. But then all the other ones they show you, you see the squared, even. That one doesn't have either. Then you have a cube, it's odd, third power. You have a cube root, it's also odd. This is what that graph looks like, the one that we're working on now. But you have several of them here. So knowing what that graph looks like and knowing the type of symmetry it has will also help you. So this one is odd, and now I want to answer some of those questions that I were speaking of before. Does this graph have any shifts left or right? So as far as that description, so let me also show you that. So if you go back to the module 2 and the parent functions plus, I'm going to scroll all the way down to the bottom where it shows the equation for transformations right here. This guy, what I showed you, what I wrote down. Do I have anything that is adding or subtracting to the x in the grouping symbol, or do I have anything at the back? So when you look at this equation, there's nothing under the radical, okay, that would shift that left or right, which that would only affect even. This is an odd. I'm looking for something at the back that was added or subtracted. So with this type of function, what I'm wanting you to understand is that in the same way that we have that parent function, this is a b, sorry, this is b x minus h and then plus k. So in the same way that we have this function, all equations can be written in that form. So with this cube root, it'll look like this. The a would be on the outside times the cube root, and then you'd have something times your x. Underneath the radical, that's your grouping symbol here, and then plus k. So if I have something on the outside, that's going to be my shifts. And I don't have anything like that, okay? And since this function was odd, it will still have its odd symmetry, okay, without me having to go through the solving process. All right, so this one was even, okay? And remember, this one affects odd and x-axis. This one affects even or y-axis. So if I see something that's even and it has a shift, it's probably not going to be even anymore. And this minus 2 is not in here with the x, so that would be acting like this. That would only move it up or down. So because of this minus 2 not in grouping symbol, so what you would see if it was, you would see something like this. Y equals absolute value. You might have like an x minus 2 instead. And then you could still have a plus something out here. Okay. If it was in there, it would shift it left to right. It would be corresponding to this h, and it would not be even. So graphically, what that would look like, you got an absolute value, and then this would move it left or right to. And then the one on the outside, which we actually had a -2, it will move it down to. Okay, one of them is still even when you flip it across the y-axis. One of them is not, this one. And that's because of that. So we don't have that. We don't have it inside with the x. So this is even, okay, according to our parent function. Let me go back and show you absolute value. So both parent functions have most all these graphs. So here's your absolute value. It's telling you domain and range, some of the inverse functions, restrictions, odd/even. It tells you that it's even here, and then it shows you that general form. So this is really good at helping you identify what the transformation would be like. And since there's nothing in there with that h on r's, then it will still remain an even function graph.